For this last page of your handout, this is a lot of practice. So for C, D, and E, I hope that you are now ready to move into just doing this yourself. You're welcome to try this, hopefully you have already before watching the video, and you can just check your work. Our domain values are the values for which the function exists in the x direction. And this keeps on going, starting at 1 and then going in the positive x direction. So our domain would be an open bracket 1, comma, infinity. And whenever we have an infinity symbol, we use a parenthesis to pair with it. Doesn't matter if it's going to positive or negative infinity, we use a parenthesis to close it off. Our range is how far up or down it exists, and in this case we have a graph starting at 0 and continuing on with an arrow to up and to the right, which means this function will continue on to positive infinity as well. So our range is open bracket 0 to infinity, close parenthesis. This does represent a function because it passes the vertical line test. For the second one, we have an absolute value. The domain would be all real numbers because there is a graph everywhere on this function. So our domain is open parenthesis, negative infinity to infinity. And our range is 0. And we're going to include 0. So open bracket 0, comma, positive infinity, close parenthesis. This is a function because it passes the vertical line test. So we'll say yes. Our domain for the circle given is -3 to 3. Our range is -3 to 3, but because this is not a function, we're just going to say no and move on. This last part of the handout is relating to zeros of functions. Now, all of this stuff is just going to be helpful for you moving on into applications of functions, but in general, we will be using the zeros of functions to make sense of quadratics, linear functions, and absolute value functions. If we want to find the zeros of a function, we're trying to find what values of x will give outputs along the x-axis. Well, remember, f of something will be represented with y, and when y equals 0, you get a line along the x-axis. Whenever you're seeing a function equal to 0, it's saying, where does the graph you just plotted intersect the x-axis? So for this first one, it would be -2. X equals -2. This is a linear function that has a positive slope intersecting the x-axis at -2. For the next example, we have a parabola, and it never crosses the x-axis. So this one has no zeros. No zeros exist. At least no real zeros. We'll talk about that much later in the quarter. And then lastly, we have this absolute value function. We want to know where this absolute value function crosses the x-axis. So where does it cross the line y equals 0? And we have 2 points. We have -1 and 3. So x equals -1 and x equals 3.